Evening there, CJA Math Scholars. I'm going to walk you through homework 1.2, transition worksheet number 2. I'll be doing the odds. Follow along exactly how I do them so you can do the evens. So it says replace each blank with a number so the fractions are equivalent. What does the word equivalent mean? It means equal. Yes, you should write this down. So basically I want to make 1/5 and some other fraction equal. So there are a couple ways I can go about this. The first way is I can say, all right, what number times 5 can give me 35. So how do I make this right here the same denominator? Well, I know that 5 times 7 will be 35. So up top, I'll just do 1 times 7, and I get 7/35. So 1/5 is equal to 7/35. This will be your answer. All right. Number 3. 1/6 is equal to blank over 24. So what number times 6 is equal to 24? That's times 4 times 4. So I'm saying 1/6 is equal to 4 over 24. That's your answer. What about a problem like 5? They switch it up on us, right? They say, all right, 4 over blank is equal to 20 over 45. So 4 times what number gave you 20? And in this case, it's 4 times 5. And now that's interesting because if I put the times 5 here, this is saying what number times 5 will give me 45. And in this case, that answer is 9, right? So 4/9 is equal to 20 over 45. That was a tricky one. There's another way to think about that one as well. So I'm going to put it over here, and yes, you should write it down. So 4 over something is equal to 20 over 45. The other way to think about it is to go backwards, right? 20 divided by what number gives you 4? Well, I could say divided by 5. And 45 divided by 5 will give you my blank number, and 45 divided by 5 is 9. So either way you do it, you should get the same exact answer. Number 7, 1/3 is equal to 27 over some number. So 1 times 27 is equal to 27. So then 3 times 27 is equal to some number. Now, I don't know my 27s off the top of my head, but I can sure figure it out by doing 27 times 3 off to the side. This is 21. Put down your 1, carry your 2. 3 times 2 is 6, plus 2 is 8, so 81. So 1/3 is the same thing as 27 over 81. And number 9. So again, kind of a tricky one because you can't do 24 times what number gives you 4, right? You would be working with fractions there. But we can do backwards, right? We can say 4 times what number gives me 24. Or you can do 24 divided by what number gives me 4. I like the divided by one. So let's do 24 divided by what gives me 4. Well, the answer is 6, right? So then 18 divided by 6 should give me 3. So 18 over 24 is equal to 3/4. So you have to work with both. You have to decide, all right, which one's the better one? Should I be multiplying here? Should I be dividing? For instance, like in number 2, it's not going to help you to multiply, right? You should probably say, all right, 15 divided by what number gives me 5? This divided by what number gives me 2, right? So if I do by 3, then by 3, so what number divided by 3 gives me 2? Or think backwards and say 2 times 3 is equal to what number? I've already said too much. That's an even. I probably shouldn't have helped you on that one. I'm going to move on down. All right, this is just a quick review of making sure you guys know how to do mixed numbers to improper fractions. So all of these right here are mixed numbers. I have a whole number and a fraction. That's a mixed number. So to turn it to an improper fraction, it's very simple. I do 5 times 7, which is 35, and I add it to my numerator. So 4 plus 35 is 39, and I keep my denominator over 7. I will do that one more time in number 15. So 9 times 4 is 36. I add it to my numerator, so I have 37 over 4. Make sure you shoot these down here in the answer space so I can clearly see your answer. We'll be good to go. 17 and 19, it's the opposite. So we have an improper fraction. That's where the numerator is bigger than the denominator, and I want to make a mixed number out of that. I want to ask myself, okay, how many times can I fit this denominator divided into that numerator, and how much will be left over? So I'll be doing a division problem. So basically I'll say 2 into 5, denominator into numerator. How many times does 2 go into 5? Well, it goes in there 2 times, and I have 1 left over. The 2 is my whole number, The 1 is my numerator, and I keep my denominator, so 2 and 1/2. Let's do that one more time. 8 into 17. 8 goes into 17 2 times, because that's 16, and I have 1 left over. So again, the 2 is my whole number, the 1 left over is my numerator, and I keep my denominator, 2 and 1/8. Let's flip over the back side. Comparing and ordering fractions. So these are inequalities, right? We learned about inequalities today. That's a mathematical symbol telling us that two things are not equal, right? So to do this with fractions, we can do it a couple of different ways. One, we can ask ourselves, and we're going to write this down, ask how many more in the numerator to make a whole. All right, so that question basically asks, all right, how many more numbers do I have to add in the numerator to make a whole? And sometimes that question helps us out, and sometimes it doesn't. And the second way we can do it is with the butterfly method. So for instance, in number 1, 2 over 3. How many numbers do I have to add to 2 to make this a whole? 3 over 3, right? Well, I just have to add 1. 3 over 4, how many numbers do I have to make that a whole? 4 over 4, well, I just have to add 1. So really, some of you might say, well, they must be equal then if they both just have 1 to add. Nope, let's check it with the butterfly method. The butterfly method says, all right, what is 2 times 4? 2 times 4 is 8. And what is 3 times 3? 3 times 3 is 9. See how it makes a little butterfly. Which one is bigger, 8 or 9? Well, the 8 is smaller, so 8 is less than 9. Always each the bigger number. So you could say 2/3 is less than 3/4. For those of you that know your decimals, you know that 2/3 is 0.666 repeated, and 3/4 is 0.75. You might say, well, that number looks bigger because it's longer. If you add a 0 there, 750 is way bigger than 666. Right? Let's do number 2. Sorry, not number 2. That's a even problem. Let's do number 3. So let's do this with the butterfly method again. So 5 times 12 is 60. 7 times 8 is 56. And then just ask yourself, which one's bigger, 60 or 56? 60 is bigger. So 5/8 is greater than 7/12. And this one also makes sense using the first method, because here I only have 3 numbers to add to 5 to make that a whole. I have 5 numbers to make that 12. Because I have fewer numbers to make a whole out of it, that means it's a bigger fraction, right? It means I have like 5 pieces of pizza left here, where I only have 7 out of 12. I've given 5 away. I got more pizza left in 5/8 than I do in 7/12. Number 5, let's do the butterfly method. 3 times 3 is 9. 1 times 9 is 9. So what does that mean? 9 must equal 9. 3/9 is equal to 1/3. Another way to say that is that these guys are equivalent fractions, right? They are equal. Number 7, 5 times 8 is 40, and 6 times 7 is 42. So which one's bigger, 40 or 42? 42 is bigger. So 5/6 is less than 7/8. Now you might be asking yourself, well, but wait, they both only have 1 to make them a whole number. That's correct. Now, ask yourself, would you rather have to cut your pizza up into 6 and give away slices of 6, or cut your pieces up into 1/8 and give away slices of 1/8? Well, if you give away slices of 1/8, that means you have 7 slices left. If you give your slices away in 6, you only have 5 slices left. Which one has more pizza left? That's the 7/8, right? So that while they both only have 1 left to make them a whole number, because this one has a larger denominator, that means this fraction is going to be larger. You've given away less of your pizza than in this one, where you've given away more, because the slices were bigger, so you give away more, right? It's a little confusing. We'll continue to talk about it, though. Lastly, number 9, 4 times 3 is 12. 5 times 2 is 10. 12 is greater than 10, so 4/5 is greater than 2/3. Very similar to this one, right? They both only have 1 left to make them a whole, but because this denominator is bigger, you have more pizza left here. These slices were bigger, so giving away 1 is kind of a big deal for you, because you only have 2 slices of pizza left. Here, you have 4 slices of pizza left. All right. I will be doing 10B. You guys will be doing 10A. So we're taking a look at this diagram. It says, how is the world's wealth shared amongst its population? The people here is a percentage of the population. So this is 68.7% of the population, 22.9%, 7.7%. And this is how much money they have. So 3% of all wealth, 13.7% of all wealth, 42.3% of all wealth, and 41% of all wealth. So what percent of the world's population earns greater than, let's put a greater than sign, $1 million? So this is less than 10,000, between 10,000 and 100,000 and a million, greater than $1 million. What percent of the world's population earns greater than $1 million? Well, that's simple. That's 0.7%. Crazy. That's a very, very small percent. Not even 1% earns greater than $1 million. But look at all the wealth they hold. They hold 41% of the wealth. Less than 1% of the people, right? If I picked out one of you in the classroom, that would be still greater than 1%. It's like going into our classroom and saying one student in this classroom owns 41% of my $100. I'll give 41 of $100 to this student, and then everybody else we have to divide it up amongst you. That is crazy. That's an example of inequality that we face in our world. I want you guys always to remember 4. If you're still watching the video, you're writing this down, you're getting credit for it. 4 billion people in the world live on less than $4 a day. Always remember what's really important, and why you get your education is so that you can go out, be the problem solvers in this world, and help us fix problems like that. Call me if you have questions.